Audio test 1 2 3. Someone comment. Tell me if you can hear me. Alright, audio's on. Don't know if you can hear me or not. Someone comment, please. So you say it's low, like you can not hear me well. Okay, so how does that sound? Does that help any? Can you hear me better now? Better yet, we'll just crank it all the way up. How's that sound? Alright, Phil, I take it you're not, by your question, I take it you're not familiar with how PCB stuff works, so we'll try to talk a little bit and tell what I'm doing. For orientation, here's the board. The red is the top layer, the nearest layer as I'm looking down through the board here, and the blue is the back or bottom layer. You can see in the blue here is the F7 here. This row and this row of pads here, that is the OSD chip. These pads around here, that is the SD card. The red here on the front. Let's see, the red here, this is, let's see, that's the gyro here. And these pairs are some capacitors and stuff. This here is the compass, and this is the pressure sensor. Those two I think are going to stay there. This one has actually, this group actually has to move over here further later. These three pairs are capacitors here. Rest of all these circles, these are will be pins. Red here is the USB port, and all the blue here is this is all the various power supply stuff all packed together here. So here's what the front looks like, and there's what the back looks like. This way you can see kind of better what represents components. This is the RX plug here. And then if I go to the back, we have the F7 and all the decoupling capacitors here at the corners, the OSD chip and its crystal, and a bunch of caps and resistors. Here's the resonator for the F7, and here is the boot and bind buttons. This is the 5-volt regulator, and this is the 3.3-volt regulator. And somebody's at my door. I didn't do it! Was I supposed to? Yes, nope, not that light.
No, I don't. That's okay. Just leave that there. Yeah, okay. Yeah, I can follow that easy enough. Okay.
Is he liable to be back in here, Tracy?
You don't have to go back in that room, do you? No.
All right, thanks, Tracy. My manager and repair guy finally, after God knows how many months, looking into fixing a leak I had. About time. I've had a leak that's leaking into a light socket, and I've not been able to use that light for God knows how long now. We discovered it last fall, when I found under the light there's a mysterious water spot after a couple days of heavy rain. And I mean, I've been here 10 years and had never noticed this. And I watched the spot for a couple of weeks. I couldn't figure out what on earth had made the spot. What it was the kind of spot where you get a leak and then it dries and leaves a kind of a ring, and that's what I saw. And initially it just looked like a shadow on the rug. I ignored it because I had never noticed it when it was wet. And finally I went and realized that that's got to be a leak, and I'm looking up at the ceiling where it is, and the only thing up there is a light that has one of the globes around the light. And I went to start to take the globe off to look around, and I noticed movement. The globe was full of water. Yeah, I don't think I need to say any more. So anyways, power supply. So there's your power supply, and I think that covers all the main components. The the blue and red lines are the traces that'll be on the circuit board. The yellow lines here are connections that I need to make. So for example, this line right here, I need to some point I need to make a trace that runs from this circle over to, yeah, let me see, that line goes to this pad over here on the F7. So that wire got to cross all these other wires, or something got to go around something, and so on and so forth. And as you can see, it's quite a maze here. It's going to be some fun for various levels of various descriptions of fun. It's going to be a fun time here. Nope, not working on that one yet. So what I'm working on up here at the moment is these two wires have to cross these two wires somehow, and there's a dozen ways to do that. I'm trying to figure out the best way. And the fun part is going to be these two wires also, as you can see, beginning of this wire and that wire, the yellow, they go over, let's see, one of them has to make a pit stop. Looks like they got to make a pit stop on these two pads on the, let's see, what's that? That's the, oh, those are going to be SPI lines, SPI bus, so they're stopping on the, that's the barometer, and then they're going over to two pads on the compass. Yeah, so that's going to be the SPI data and clock lines. That's why they're coming over here. This is the SDR, that's the SD card. Yeah, that's the SPI MISO and clock. There should be a third line with those. That's going to be that line. And what's that line? That's going to be the chip select. So there's two more lines that at some point I've got to run them somewhere. I'm not sure how that's going to work, but sooner or later. Michael, I'm assuming you're referring to these lines that I've just been describing. So I think I probably have answered that question. Yeah, these are yellow. Those are green, at least on my screen. I know the quality coming through YouTube isn't the best, but I only have one meg out, so it's doing really good for 1 meg, I'm pretty sure. So what I'm going to have to do here for these lines is one of these pairs of lines is going to have to switch over, at least temporarily, to the top, and the trick is figuring out what's going to, let's see, for the moment I guess I'm going to, let's see, F6, move these here, and for the moment we're going to change that and that, not that one, that one, to the top. And yes, I know they're overlapping at the moment. That's the fun part. I get to does that work? And no, it doesn't like a lot of things. I just did an error check to see what's. It's complaining about a lot of things. What are these? Ah, okay. So I've mentioned a number of times where I have the clear area around my holes, so that you have room for the screw heads and stuff. And so what it was just telling me is that a couple of the traces I have here are inside that border, so I need to make changes here, which I know. Right now those are just quick lines to get the these are called air wires, the unrouted parts, those temporary lines get my air wires out of the way, out of the big rat's nest here, so I can see more what needs to go where. Later I'll take and trim the corners off these lines so that they're angled like I did here, or I may move those lines completely. Things change. Everything I do today may completely change before it's final. Yeah, Michael, this is not this level. I mean, if doing a project with half a dozen parts or a dozen parts isn't really a big deal, even for a beginner. But something at this level is not for a beginner or even weak at heart. This is not something you do in 2 hours. Some of the softwares to do this have various levels of help that will automate some of it. Eagle has what's called an auto router, where it'll automatically try to run your traces as best it can. In my opinion, they all suck, and so I do all the routing myself. And okay, yes, it takes a little longer, maybe a lot longer, but it allows me to keep track of things and mitigate some possibilities that the auto router can't understand, as far as electrical things that need to be certain ways. And I've just never been impressed by the work the auto router does, so I basically refuse to use it. I don't know, it's what works for me. Doing this by hand is very much like doing a high count puzzle, and that's something that I've been very good at since a little kid. It's just something some people can do and some can't. Some people do it naturally, like me. Some people can study and do it, and some people could study a lifetime and still not be able to do it. And that's pretty much like anything else. I have a game that I really like on Android, that after I'd played it for a while, I realized that it has a lot in common with doing this. The game is called Flow. It's basically a connect the dots thing, but the dots are rearranged in different patterns, and you've got to make the line go around the other line to be able to get back to the other dot. And it has a lot in common with us as far as the kinds of things you've got to watch for. It might be a little bit easier than this, but it has some of the same principles are involved. It's also very addicting. So right now my concern is looks like I need to move these over here more, and remember that the blue is on the back, and the red is on the front, so just because these look like they cross each other, they're on different layers, so it doesn't matter. So the only thing I'm worried about here for those blue wires is this pad over here and these pads here. Now these two red wires I can't move over here, but I can get them out here where I have a little more room so that they're not bothering each other. And here's another one that's too close. When I run my error check, it marks that's too close. I think I'm going to ignore that for the moment. I'll fix that up later. Ah, yeah, the light leak. Never had a short. I even actually, at the time before I realized what it was, had been using that light. It was on with the globe full of water. Yeah. Never had a problem. Never shorted out a fuse. Yeah. the guys upstairs apparently working on it now. And apparently we realized that we've noticed rings in the globe years before. In fact, when I moved in, it was noted that it was dirty and there was something that looked like a water line in it, but no sign of water. And we just washed it out and put it back up there. So the leak in question has been there for more than 10 years. I've been here 12. So it's been around a while. And this is a light I use all the time. It's the hallway light. Yeah. So let's get these down here further. We'll get them out of the way. We'll figure out how to terminate them later. Nope. Don't do that. Bring this one down here somewhere. Not in the final location, but yeah, I'm not gonna worry about that for the moment. And these can go. Bring these up at this point. And this point, and okay, fine. Those lines can nuke. No, just the one, thank you. There we go. And we'll just drag these all the way up there. So it looks like that one I can just, okay. What's your problem? There we go. Well, that doesn't sound good. I can hear him walking across my ceiling in a ceiling creak. Yeah, okay. We want you to fix the leak, not make more. Should ask him if he'll fix my ham radio antenna while he's up there. Can you guys hear that stomping? Good heavens. Making an awful lot of frickin' noise up there. Alright, we'll do this way. Nope, not that one. We go on the bottom. There we go. each other. So now we got red and blue crossing like that. Now I get to do this. Now what do we got? Okay, we got those up there. Still got to figure out how to get the USB lines here. We've got to go across all of this somewhere and up to there. That's what's making all the noise. Well, that looks like a fun one to manhandle. Well, that looks like fun. The repair guy is an elderly guy. I just watched him manhandle had to be 30-foot extension ladder single-handedly. Yeah, I wouldn't even want to do that. going to fuss about. However, I got lots of room here. So I can take, so you can move these. That. That's not going to be enough either, is it? Top one. Let's see if that'll do it. Was not what I had in mind. Yep, so that'll be good enough there. So this one there and there and there. And then what on earth is it complaining about here? Restrict what? Oh. So I'm looking at this here. This mark here is where it's marking an error based on rules I've created. And in this case, it says this is encroaching on a restricted area, and I'm looking at this going, what restricted area? Well, right now I have it so it's only displaying the top and bottom layers. And what's missing, what it's not showing, is this red area here. And that red area is part of the, yes, it gets messy when I'm showing all this. But you can see this, let's see, we've got a red shaded area that goes through this area here. This is part of the SD card slot. And according to the specifications on the data sheet for the slot, there is not supposed to be any metal in that area, so I built in a restricted area for this purpose. But because it's not normally shown, I didn't realize that when I put this this via in here. So I need to move that via, which is fine. I can move that easy enough. Got down here just one. And what this via is, this is tying a via, for whoever's watching, if you don't know, is basically a hole through the board connecting multiple layers together. In this case, this is connecting the 3.3 volt rail from the. There's also two inner layers, so one of which is ground, one of which is 3.3. This is why I'm using a 4-layer board. Otherwise, a board like this would simply not be possible without multiple layers. There is no way you're going to route all the power around on just the 2 layers with everything else. It's just not going to happen. And especially when you get something as crowded as the 16 that I did, the Anubis. There's no way I could have done that without the multiple layers. But anyways, this is connecting this little area here, which is the last pin of that row, and one of the decoupling capacitors from the bottom layer into the inner layer is what this VA is doing. And so what I've done is I've just pulled it down a little bit. It's still within this square. Let's do this. So now you see this is the main copper on the bottom, this area out here. And I have marked off that square you saw is a separate polygon that is isolated from this. This is all ground by default out here, and so it's coming through this pin here. That's ground. This pin here is 3.3, and this capacitor is the decoupling across from 3.3 to ground, and this via here is tying the 3.3 layer, this little bit here, into the internal layer of copper. And there's going to be holes out here to tie this ground plane into the inner ground as well. I just haven't put those on. Those will go in last wherever there's openings to do so. You can see over here, here's the other one I was saying that where there's interference here. So I'm going to have to cut those down similar to what I just did over here. I don't like that poor setup like that. Oh, well, I'm at it. There. Now we're done with that area. What one is it complaining about? Is at the wrong angle. Go on, you have to the wrong angle. Actually, it is. We'll have to do something about that then, won't we? Being so close, and so here's another one where I have quite a number of possible ways I can mitigate this in this area here, because I have to at some point bring this wire in all the way over to here, and what I'll do is I'll jump it over to red with a via here. I'll jump it over to the top side and bring a line across here, and then jump it again over here back to the bottom and down to the pin. But before I do that, I've got 1, 2, 3 more connections from these pins up here that I've got to come across that area. So I've got to figure out how I'm going to bring those pins across before I may bring this across. And that's going to get interesting. Limited options, and I'm not sure I want to play with that yet just yet. I'll leave that till later. so we've got those over here, we've got those coming down. So here's another one. Let's see if we can simplify this. That wire across there, does it go anywhere else? No, it's only coming across there. And I'll note again that these three capacitors sitting here won't stay here. Ultimately, they need to go somewhere out here in this area. But right now, I've left them sitting here just to keep them out of the way, so they don't make it even any more confusing in this area for me to see what's going on. These, I'm not worried about routing these because they're just ground to 3.3 decoupling for the SD card, so I can put them anywhere. There's no routing to be done because it's just going to be a via on each end of them for connecting them to things, so I can drop them theoretically anywhere, but they need to be close to, let's see which set of pins. I don't know which one is ground, but there's the positive pin of these. Looks like this one here, since I don't see an air wire to it, looks like that one there is going to be the ground. So they're going to need to want to be close to this pin in particular, and ideally they're going to want to be in this area right here, just to be close to the power and ground pins of this device. Problem is, and the reason I haven't put them there is because there's going to have to be quite a few traces in this area as things link. This is going to be probably end up the primary linkage area between the pins on all four of these devices, the three sensors and the SD card, and probably a bunch of traces and vias from in this area going from these across the board to connect to the F7. So I'm trying to leave that area open for the moment, and we'll shuffle things when I get down to it. And you can see here, you see the highlighted greens. Those are other vias for the 3.3 layer, where I'm connecting. Again, there's decoupling capacitor here and here, and two more here, and this here is just a positive pin, a power pin for the F7, and there's a via I've placed for it. That via there is almost certainly going to move, possibly in here, but I don't know yet, because I know that this group here, as I noted earlier, this is the gyro, and while it's not absolutely required, it is ideal, it is preferred that this is near the center of the board. Well, the center of the board is somewhere in this area. I think it is, yeah, this here is the center of the board. So this whole set of parts is going to move up into this area here. It still won't be centered, but it'll be a lot closer. But again, that will happen later when I have a better idea of how all the parts are going, how I'm going to get signal to all the places it needs to go. And then I'll be able to have a better idea where I can put that via. back to what I was looking at to start with here. Trying to figure out how to get that across there and here. And the only way that's going to happen is to run on a couple of vias and run it on the red side. So I need to put a via over here. I need to name that via to match this. This is this is 5 volts. Okay, so let's name this 5 volts so it'll connect. And now we see an air wire over there. And I'm going to need another one over here somewhere. So where's the best place to put those? Is going to be, we're going to put it right here on this pad here. Problem there is there's a little tiny thing there that I would have to make a trace for. However, instead I'm going to do the same thing I did for this and make a polygon here. So draw a little polygon here. That we don't need it that big. We'll just make it a tiny thing here. Make it bigger here. And then I need to name it 5 volts. And now, if we watch closely, that trace will disappear because that trace is no longer necessary. I just enlarged the pad basically. So, if, like I did before, and show you this, how it makes a whole pad within that polygon that includes the via. Now, without that pad, electrically it would have been fine. There wouldn't need that trace because the via is completely contained within the existing pad. However, the software doesn't know that and needs to have that connection or it'll complain to you. So I do this to keep everything happy. And it's not a bad way to do it anyways. And let's see, I'll do the same thing up here. I'm not going to put it directly on the pad in this case for reasons. We're going to put it out there. Although, yeah, for reasons, we're going to put it up there and actually make a trace to that one. Just because. I may change my mind later in case I need to make a trace through here and move it, but that should be fine. Let's see. Now we have vias, but there's no 5-volt layer that it'll allow for it to connect to. So what I'm going to do is go to one of their internal layers. This is a ground layer and this is the 3.3 layer. But this is, since this is a power layer, we're going to take and let's see. Oh crap, how am I going to do this? I got to so I can ice it. I need to be able to see that out there. And that there. Apparently nobody wants to watch me anymore. I must have scared them all away. inside the board. Now I move this back where I had it, and I can reconnect that, and then I can come back to the inside here, and I moved this via, so I need to move that accordingly. Now, the downside of doing this, so here's also this is also the 5-volt layer. The layer I'm looking at is the 3.3 layer, but this little area down here marks, this is a 5-volt path. This is from the you'll see this is the dotted line here. This is right here is your main input power input. Actually that's not 5-volt. This is battery level. No, it's not. That says 5 volts. Are we? How did we set this one up? Where's my power? My power is. Did we make this for 5-volt input? I don't think so. Power 5-volt, voltage in. This is battery. Where is? Okay, so going back to the. So this one here is voltage in. This is our main power input right here. So this is going to be battery level power, along with this pad here. This pad is part of the protection diode here, and then this is ground. This connects through only to the diode. Then we get to the other side of the diode and highlight. So here's the other side of the diode. That connects to the let's go to just the okay, so here we have showing just the bottom and the power plane inside. The blue is the bottom layer. The dotted red, or the striped shaded red, is the internal power plane. So we have the main input, power protection diode. This is our 5-volt regulator, and we have a couple of capacitors here going for, again, these are decoupling, so we got ground and power, and then these pins of the chip are primary input, and then the output, 5-volt output from the chip. Come back over here briefly and highlight that, and then come back here. Why do I have Okay, so this what's highlighted is the 5 volts out from the 5 volt regulator. We have a trace coming out and going to our second protection diode there, and the other end is just off the screen above, and going to the power layer inside. This is actually the output pin here. Oh, these are decoupling capacitors over here. One here, one there. Here we'll do. If I can get this right. No, might help if I had the right thing selected here. Let's try that. There we go. So we got a couple capacitors here. Why do I have those capacitors? What are those capacitors? Those are... Okay, that's going to be this capacitor and this resistor is what that's going to be. And then the inductor here is this big thing over here. So anyways, here's the 5 volts output on the bottom layer, the blue, and that's connecting to the inner power layer, which is primarily 3 volts or 3.3. But this little area here marked off in the shaded right here, this kind of design here, is a spot marked out for 5 volts. That's connecting across over here to the resistor and capacitor I showed a moment ago, and then the one end of the protection diode that goes over to the input of the 3.3 regulator over here. And it also goes over here, and this is big because this is going to be relatively high current, and this is going to be the 5 volt output for, or 5 volts output for camera power, is what this is here. So then we have, here's the inside layer, that's the power plane, everything but this mark here and this mark here, which we just did and nobody was watching. Everything else, anything connected to the rest of this area is 3.3. But there's the power supply. This is our main input protection diode, and this is our 5 volt, 3 volt and USB protection diode. Back to routing, we were working on how to get, getting power from marker 5 volts. So we gotta get 5 volt from this highlighted over to that little highlighted area. We've got that. Excuse me a minute. We've got that connected. That also needs to come down to these headers for 5 volts. So these are going to be, I'm actually not sure which headers these are, but 5 volts, I'm guessing those are going to be serial ports maybe? Not sure. But I've got to connect down here, and like before, I've got to be careful. You know what? just take, let's see, this has to go, nothing else down here to worry about. So I can take and move those, all of this, boom, 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 and then I can go from there up to, make sure I'm connecting to that. Well, that's not good. That's better. Now I don't have to, by changing that, putting that all on the, make sure I'm not interfering with anything. Yeah. So the potential problem here is that this, which is the 5 volts line, what we're looking at is the power plane, which is supposed to be 3.3 volts primarily. Any area except the red that you see is all 3.3 volts on this layer. So let's do this. So there's the copper for this layer. This area down here is our 5 volts in the power supply. The separated area out here, and this is what's coming up to the OSD chip here, and on the other side of the OSD chip. So the problem is this line kind of cuts the 3.3 plane in two. Now it's still connected up here from side to side, but if and I don't believe I have to, if I were to need to put a VI connection to 3.3 over in the area on this side, if I were to need to put connection to 3.3 anywhere over here on this side of that shaded red line, it's still connected to the rest of the 3.3 layer up here, but it can cause a lag and or a voltage drop to that power, which for simple low frequency, if any, like simple project stuff, that's not a big deal. But we're working with high speed signals in this project. So if I were to need 3.3 volts anywhere over here, and it doesn't look like I do, this line cutting this in two could be a problem. I don't think any of this needs to be 3.3 over here. I can actually find out really quick, like find me something that's 3.3, that's 3.3 there. So Okay, so I do actually have something over here that's 3.3. I have this pin right here that is 3.3, and therefore I'm going to need to consider, one, what use this 3.3 will be, what that 3.3 is going to be used for. I don't know offhand what this header is going to be for. How do I find out here? Let's see. Which header is that? That is J22. J22, this is the 280Cs, so current and voltage sensors, presumably, although they can be used for other things. One of them we have 5 volts, and one of them we have 3.3 volts. And I'm guessing that this pin here is also supposed to be ground. I'm not sure why I don't have it. I'll have to talk to Michael, because I'll bet that one's supposed to go to ground as well. But the pin in question, the pin we're looking at, is this here. So this here is the pin we're looking at for 3.3. And if that were to be used as a current sensor, I'm not sure why it would be, but if it were to be, being separated like that could be an issue. So again, this is something I'll have to look at later, and I may have to take and this bit up here should be fine, but I may have to take and this section and or this bit here, I may need to move back to a different layer so I'm not cutting up the 3.3 layer, so that this can be more directly connected to the rest of the 3.3 area. I'm going to leave it like this for now and worry about that later. Right now I'm mostly concerned about getting primary traces put in order, and details like making sure this 3.3 pin has the juice it needs will be dealt with later on review. Now what? Let's see. Sorry, I'm not looking at the circuit right now. I'm dealing with something else. back to circuitry. So I got this one, it wants to go up there. If I put that on red, then I can do this and put it right over here. And then I can take it right straight up. Because there's the only other thing over here is that's crossing this are these two wires here. But I can bring this all the way up on red side into that. And what signal is that? That is serial 3RX. That one needs to go over to the that's the compass. So that needs to come over here. So that'll be another wire that's going to come across this spot to deal with at some point. And in fact, we're going to take and do that now, because that'll help us anyways. Putting this here now will, like I said before, get my air wire out of the way. Where I'm placing this trace now is almost guaranteed not to be where it ends up later. I mean, it'll come across roughly the same area. It has to. There's not a whole lot of choices. But the final arrangement of these traces in this area, as noted earlier, is guaranteed to change. In what way, I don't know at this point, and for the moment I don't care. These two lines, these two things here, let's see, this one comes down here, and there's just not space to bring it right here, which is what I do ideally. And then I need to do, this trace needs to go up there too. So this trace, no, I can't. So this trace is stuck. It can't go anywhere on blue. What trace is that? That is chip select for serial 2. So that is not a high-speed line. Let's see. What am I looking at here? So let's bring these over here. And then, since this is not a high-speed line, I'm not worried about making it take a longer path. make a final termination to that, because that's also guaranteed to change at some point, probably not much. This part is fine, probably, because I got nothing else going on out here. There's no other air wires to worry about out here, which is what my main goal right now is, to get all these air wires out of the mess is the idea. So I'm basically putting traces in the general area where they're going to go, and at least the general paths they're going to take, not necessarily final. Okay, I'm clear there. Where am I not clear? That's the one I already know about, but I'm ignoring. Where am I in restrict? Oh, got those two. Okay, so that's those 4 traces there. I'm not worried about those. I'll deal with those otherwise. How do I get that pad out here? Which pad? What is this signal? This is SPI3 data, and that's a relatively high-speed line. Well, that also has to go. That's going everywhere. So that's going from here. Let's see. No, that's only going. Yeah, that's going here to the SD card. No. That's not going to the SD card. This is the, okay, this is the OSD and the pressure sensor and the compass. And those watching, the chat is on. You can comment. I am checking the chat from time to time. Not so much the Facebook. I'll look at Facebook thread once in a while, but the YouTube chat here, I try to keep half of an eye on. Let's see. So really, the only thing I can do here to get this out is move up to red, move up to the top layer. Problem is then it's one more thing I've got to cross here. And like everything else, there's 25 ways I can do this. Let's see. I've got to have at least 2 vias. Got to have one here. Name this. Copy paste is so nice. I don't think I can put this here. Oh, it is cool. That'll work then. No, it won't. Do not want it like that. So just because. Put it there. That in. Oh, don't want to do that yet. And the reason is that if I put that circuit in there, then I don't have an air wire to grab at this point for making my ladder trace. So if I leave that open like that, I can grab that air wire to make my red trace. somewhere down here, don't know where. I'm going to need to put another via. Let's see, and I've got to remember that these three caps are not staying there, so I'm not worried about them being in the way. Let's move these over here. So they're out of the way. So I can take my trace here. Kill that. Trace. Am I actually clear? Cool. Okay. And then now I can take and do that. Now I can take and finish up and do this. Oh. Get my angles right. Do it that way. And now you can, if you know electronics at all, you know why I didn't really want to do it this way, but this makes this angle here literally makes the electrons bounce, and that can cause problems. SPI is going to be low enough frequency that it shouldn't be a problem, but it's something that I will take and come back and look at later when I have most of the traces worked out and I can start fine-tuning things. But for now we'll leave it like this. And that is all of the traces from this area, which is really nice. I figure out what to do with these. The USB, how am I going to get those out? Let's see, what have I got? I've got the USB and this signal and this signal. And that one. This one can come, if it's on blue, can come basically straight across wherever it wants to. But then this has to be on red to cross there, and that means then that vertically this has to cross either red or blue, which kind of doesn't work very well. this one can again, we're not going to completely terminate that one at the moment. No new errors, so that's clean. Left with just this one. And it goes, let's see, what is that? That's ADC. That goes all the way over there. Not sure what to do with that one, but for the moment, I guess we're going to. Nope, we want to be on the bottom. We're going to take and just blast that one over here, since it's got to go over here at some point anyways. And that gets it out of our way. And you guys, back here. No, not you. No. You go red. As usual, 25 different ways to deal with the problem. Oh, that looks like fun. Did not see that one coming. These two wires need to cross each other. We need to go this way at some point. Let's see. So here's another one of those problems where electrons don't like to make sharp turns. And for low speed DC signal is no big deal. However, we're talking USB. In this case, I definitely do not want to leave these at even the right angle, much less anything more. So, what we're going to do is, nope, red one, bring this back down, bring this down. And what we're going to do instead now we have only a 45-degree angle, which is not a problem. Wow, I have, you know what? Let's save this while I'm at it. Because my computer has of late developed this desire to, I mean, it's a good idea anyways, but of late my computer has decided to start rebooting at random. And it would really suck if I hadn't saved the last several hours worth of work. Not my first rodeo. Been there, done that. Too many times. Way too many times. So we have this side of the board done, really. I've got this signal here. That's just a power signal going to, these are more caps and resistors that can basically go anywhere. Actually, I think I think these are resistors and LEDs, I think is what this is. They're things that they can go anywhere. It doesn't really matter. I'm just going to wait until everything else is placed and then I'll put them somewhere. I mean, you can see from the air wires that they all connect up to signals over here, which means I will probably put them somewhere over here. But that's our top and there's not a whole lot of place over there. So these, yeah, so these are two LEDs and 3 resistors. And it looks like they all go to signals that are here. So both these and these are all going to want to be in this area. And this group wants to be near the corner of this. You can see right here, that's the center of the board. So as long as traces allow, I want to put this as close to this corner as I can. And so these parts here and these here will probably end up in a strip like this, sitting right across here, is probably what will happen. None of these 3 groups is fixed where they are. This one's going to move exactly where I don't know. These can't, they're where I want them, but they're free to move anywhere in this space that makes traces more convenient. Considering the mess that's up here, I very likely will move these down here closer to the inside of the board a ways to give me a little more room for traces up here. I'm not going to get any more room for vias because the F7 is there, and there's only so much I can do. But I might move them down so I have a little bit more trace space in here. We'll see. What's annoying me is that these here is what's annoying me. They want to go across to the other side. This one is on the near side. Half of these want to go to the other side, and half of these want to go up. Let's see what traces moving these affects. Okay, so I got one trace there, one trace there, and that's power. And then I got one trace there going to a processor pin. No. Processor pin, and those are going to processor pins. So I've got, that's a boot and bind, one of the 2. That's power. Nope, okay, so that's boot or bind, one of those 2. That is the power select for the receiver. Do not know what that one is. That goes to processor pin, that goes to processor pin, that one goes to processor pin. Those 2 are the LED control lines. Sucks that these want signals from all over. Alright, so let's do this then. Drop them here anyways. resistors, and that resistor. Okay, so that is the pull up for the boot, and that so we can drop that right in. Get on the right page. We can drop that. Because our boot and bind switches are right underneath here. And this is just a pull-up for the boot. So we're going to drop that right in here. An empty spot that's not doing anything. And here's that via that may move, so we may need to move this, but this is an open area. The only thing here is our power select for 3.3 or 5.0 to power the receiver. Okay, so then we have just the 3 and 5. What are these? These are the voltage divider for ADC1. That's our voltage sense. And that's our 3 wires that go up here. Nope, that is the diodes control lines are here on the processor. And the ADC1 is down here somewhere. So 3 and 5 are going to go diodes are going to go here, which puts them Okay. Well, that's why that looks weird. What alignment did I use for that? It's not aligned on millimeter or not aligned on millimeter. It's not aligned on mil. What in crap did I align that onto? Since we're going to realign it anyways. We're going to move it. Problem is, it really needs to be here. But I don't want it showing here. I don't want it showing on my board design. And I have several ways to get rid of it so it doesn't show on the board design, but I guess it's going to stay there like that. I do not feel like fussing with it. I'm just going to leave it. Yep. At least now it's in a different color so I can tell it's not part of the stuff I need to worry about. Okay. Figure out where to put these caps and stuff. Let's put these back in the default locations. I'm going to start with this one. That via is for that pin. Okay, that's what that's for. So I do not want to move that, so I need to group these without grabbing the via. And I gotta keep in mind that that via I can't move. Can I move that via? This is the via, so these two I can't move. Now this one I can move a little bit. That one I can't move. This one I can move. This is the one that is yeah, it's the one I can move depending on where I move this stuff. Ow! Stretch, stretch, stretch. So I'm looking out my window, and we've been threatened with up to 3 inches of snow today, and I have yet to see a flake. Now let's take a look at the weather report, see why are we actually going to get anything? Nope, we ain't going to get jack crap. Maybe a little bit later tonight. But it looks like all the snow is over in Lansing and Detroit area. They're getting the snow. And I'll bet they're getting more than 6 inches of it too by the looks of it. I ain't gonna get jack crap today. There's some over in Wisconsin. It'll come across the lake sometime this evening. But it's just a little bit, so we might get some flurries here a little bit later. Otherwise, no snow. That figures. Well, hey, it was 60 degrees yesterday, and then they threatened us with snow today. What do you expect in Michigan? That's typical. Ow, ow, ow! Okay, we're back. I has food in me. I feel better. Now if I can stay awake. So the next trick here, I'm afraid to tackle these wires. I really am.